Hey, and welcome back to my YouTube channel. This is Tremor, and today we're going to continue with the Programming 101 series. And this time we will do another exercise, which will be about sorting a set of integers in ascending order. And to visualize how we will implement this sorting algorithm, I will actually draw a bit. So I'm going to swap to another view. So we are now in a drawing program called Leonardo. And to implement this sort algorithm, I want to show you how the algorithm basically works. And the algorithm is called bubble sort. And let's just say we have a set of integers, maybe 4, 1, 22, 3, and 19. So what we do is, or what the bubble sort does is, we choose like element by element, starting from the left. We take this element and then we compare it to all the other elements in this array. And as soon as we find an element that is smaller than the element we are currently looking at, which would be instantly the case here because 1 is smaller than 4, we would swap those two out. So the next version of this array would look like this. And now we have that 1 in the current position. Now we are going to compare this 1 to 22. It's not larger. We compare it to 3, it's not larger. We compare it to 19, it's not larger. For the first iteration over this array, this is the resulting vector. So now the next iteration, we go to the next spot, to the next element in that array, which is 4. And since we know that 1 is already the smallest element in this list, we don't have to compare that again. So now we compare 4 to 22. It's not larger than 4 to 3, and this is obviously, like 3 is obviously larger than 4. So we swap them again. Next version would look like this. And now we compare 3 with 19, which is not larger. And if we continue like this, we will end up with a list that looks like this. 1, 3, 19, and 22. And now I would say we jump directly into code and implement this. So we are now in Visual Studio. So how do we start? We are going to make a container who can hold this set of integer values, and we will use a C++ vector for that. This vector is like a dynamic array. Pretty much it's something that is maybe C++ specific, maybe not. But it's basically like an array which is dynamic, so you can add values. You don't have to know the size of that array before the program is compiled. We call it integer set. And as I said before, we have to loop over this list of values and compare each element to the other elements. So we are just going to make a loop through all the elements in the list. Now we are going to declare and define two integer variables. We will call the first one current value, or let's call it current smallest. And we just initialize that with 0. Then we make one that's called swap, 0 as well. And what we are going to do is we're going to set current smallest to the current position we are at in the vector, which is at position I. Remember, this is a for loop. We have like an index variable, which is incremented with each iteration through the set. So we start at 0. For the sake of like a bit of a visualization, we will also print this. I'm going to make another for loop. By the way, at is a function which works on this vector, and it just returns the value at the given position. Okay, so if we run this now, we should just see the unsorted list. There we go. Unsorted integer set 4, 3, 23, 1, 6, 2, and 9. For the sort, we have to compare the current element with all the other elements. So we actually need a second loop, which is like nested in the first one. And I'm just going to copy the outer one and copy it in here again. we change the index variable to j, which is just somewhat like a convention. You call them like I, j, k. And in here, we actually have to swap. So now we say if the current smallest is larger than the next element in comparison, which is at j, we will copy the value, like the current smallest value, into the swap variable. Then we will override the current smallest with that position we are just comparing, which would be that. And then we override that position with the value we have in swap. Just to go over that really quick. Again, we have the current smallest value in here. We copy that into swap. Now we update the current smallest value with the compared one. And then we copy that swap value into the currently compared position. Okay, so let's just run this to see if we have any syntax errors or anything. That looks good. We get the unsorted list again. And now we just copy the printing of that list behind the actual sort. I'm going to put some comments here as well. And now we change that to sorted integer set, and we can remove, just leave it there and run it again. And well, that doesn't look too good. I know I see one mistake. We start from the left. After the first iteration, the set should look like this. So we start the comparison at the second spot, like this is our current smallest value. And then we compare that with 1, which is smaller again. So we swap them around again. So we have like 4 and 1. And then we swap like 1 with the next one. So this is totally messed up. So we have to let it start from the actual position where we are. And if we let it run again, there is still we are still doing something wrong. Okay, so the problem is we are not writing that value back. Like we are just swapping them, but the current smallest value is never actually written back into the into the set. So we are swapping them around, but at the end we just discard that current smallest value and we override it with the next position. So we actually have to do the following. Like after we swapped all of them and we had that like nested loop just run through, we just say integer set at I equals current smallest. And now this should work. And what we can also do is we can directly initialize current smallest with this value, so we can get rid of that line. And if we debug that now, should actually be sorted. Yeah, there we go. So now we have the original set with 4, 3, 23, 1, 6, 2, and 9. And the sorted set is 1, 2, 3, 4, 6, 9, and 23. So let's do some changing of the values. Now let's sort that again and see if it works for that as well. And that looks good. We have 1, 6, 45, and so on. So yeah, this actually looks pretty good. Let's see if this actually works with negative values as well. I have no idea. Let's see what happens. Should. Yep. Let's check if 0 works as well. Nice. So to make this a bit more transparent, we will add some more prints here. So if we let this run again, we should see the first swap here now. It swapped 454 with minus 3456. And if we let this continue for a couple of times, we will see more of these swappings go around. We swapped 3231 with 454. And to have a couple of more swap statements here, yeah, we see that it's doing what it's supposed to do. And if we remove this breakpoint and let it run again, we see the completely sorted list. And this pretty much sums up the bubble sort. I will give you a homework again to actually sort the integer set in descending order. It's actually pretty easy to do. There are also a couple of optimizations you can do here, but I'm not going to tell you what it is. You can find that out for yourself. And this pretty much concludes the episode for today. I thank you for watching and I hope you enjoyed it. If you did, then hit the subscribe button and like the video. I would say see ya next time and have a nice Sunday. Bye bye.